add and subtract rational expressions. If you can add fractions, then you'll be fine. If not, pay attention to the review part. But we are going to add with like denominators first, so that part is nice. So to add or subtract with like denominators, remember it's a number over a name, and so the denominator is the name. So we keep that same name, and then we add the top. So here's some examples you can check out, but if I have x plus 1 over, I don't know, x, can I cross out the x's? No, good job, because of the multiplication, or the addition. I don't have any multiplication. And I have x minus 3 over x. I keep the same name, so I write the same name. I add what I have, so I'm going to add my like terms. So x plus x, I have 2 of those, and it's 2x. 1 minus 3 is negative 2. And I could factor out a 2, and I would have x minus 1 over x. Either answer is fine because there's nothing I can reduce. So that's pretty much it for like denominators. So keep the same name, combine like terms on the top, and you'll be good to go. So let's do an example. So if you have this, do A. B is a little more tricky, but if you can pause it and do these two, awesome, do that. If not, all right, so we're going to keep the same name. So our name is x minus 2, and then I'm going to add the top. So I have 3x plus x, and then so my final answer is going to be x minus 2, and then this is like a 1, so 3x plus x is 4x. Can I cross out 4 and 2? Nope. Good job. All right. So that is my final answer. For B, it's a little bit more complicated. So if you didn't get the right answer, please rewind and go back. But we keep the same name of x plus 1, and then we are subtracting. So that means we're subtracting all of this. So we've got our 8x minus, and then we're subtracting all of this. So again, the key to understanding each lesson is to show all your work. So please show all your work. All right, so we have the same name, and then we've got our 8x, and then that negative sign is going to distribute to both of this. So this becomes negative x minus 3. All right, that's the key. Most people just subtract x and then put the plus 3 mistakenly. So don't do that. All right, so we have the same name on the bottom, and then we combine like terms. So 8x minus x is 7x minus 3. So if you got that without listening to me, great job. All right, if you did not get the minus 3, you got a plus 3, please rewind, go back, listen. All right, your test will thank you. Okay, guided practice, same idea. So we have all of them up here. You guys can totally do these. They're all like terms, so key is to keep the same name. So write the same name first, then combine like terms. Write the same name, combine like terms on the top. All right, what happens if we don't have common denominators? That is a great question, people. All right, so we have 1 over 3 and 3 over 4. 12 is our least common denominator. It's also called find least common multiple. So let's write steps for fun. All right, so we find the least common denominator. And later on that will just be LCD, but least common denominator. Yeah. All right, so everyone can pretty much add 1/3 and 3/4 without writing steps, but these steps are going to apply to polynomials, so that's why we're writing them now. We're writing them so it will make sense to you with something you already know how to do. So we want to find the least common denominator, all right, which is 12. So what do we do with that 12? Do I multiply both sides by 12, top and bottom? No. I would multiply this one by what? We need something to make 12, so 3 over 3. All right, and then this one, what makes 12 over here? 4 over 4. Okay, so step 2, we multiply Top and bottom. Top and bottom by what is missing from the denominator, or from the LCD, the least common denominator. Okay. All right, so keywords here are multiply. Okay. Again, it's a given fact when we have numbers, but keep that in mind when you have polynomials. So I can't just, if I took the 3 and the 4, I can't just minus 1 from 4 and get 3. So I need to multiply. I can't add or subtract. And then another keyword would be top and bottom. So whatever I do to one side, or whatever I do to the top, I have to do the bottom to make the fraction still equal. And then another keyword is by what's missing. So I'm not multiplying the whole thing by the LCD, just by what's missing. Okay, so for this one, you already know how to do, but all right, so we have 4 over 12 plus 9 over 12. Okay, so I keep the same name. 14, 4 plus 9 is 13. Final answer. Okay, so we're going to use these same two steps with polynomials. So we're still going to find the least common denominator. We're going to multiply top and bottom by what's missing. All right, but first we're going to take some practice and find common multiples. Okay, so what is the common multiple between 12 and 15? So we don't want the common factor. Like for 12 and 15, the common factor would be 3. We don't want the common factor, we want the common multiple. So how do you find that if you can't think of it? Common multiples. So we have 12, 24, 36, 48, 60, 72. So those are multiples of 12. Multiples of 15 are, let's see, 15, 30, 45, 60. All right, so and I can keep going. So I could go to 75, 80, 90, just kidding. So the least common multiple is right here, it's at 60. So the least common multiple here is 60 because 12 times 5 is equal to 60 and 15 times 4 is equal to 60. Okay. So if this was a fraction like 1 over 12 and 3 over 15, well, we could actually reduce that. So let's change that to maybe 4 over 15. Then we're going to multiply top and bottom by what's missing. So what's missing from the 12 is a 5. What's missing from the 15 is a 4. Okay, so now let's get into polynomial land. The least common multiple of the following sets, so 2x squared and 4. Well, out of the numbers, it's going, well, common multiples of 2 are 2, 4, 6. Common multiples of 4 are 4, 8. So the least common multiple for, we'll call it LCM, for the numbers, it would be 4. Okay. And then, let's see, there's nothing I can do to x squared to get x. So I want to take the bigger. And we're not talking about factors, talking about multiples. So the LCM would be 4x squared because we would just have to multiply this side by x. And so if this was 1 and 1, to get the LCD, or least common multiple, we would multiply this one by 2 over 2. And we would multiply this one by x over x. That way we would have the same name in the denominator. So hopefully that makes a little more sense. All right, let's look at x minus 2, x minus 1, and x plus 1 and x minus 1. All right, so common multiple out of that. Well, let's see, we definitely need an x plus 2 since it's there. We need an x minus 1. They both have that, and we also need an x plus 1. So the common multiple for these two would be all of this. Okay. Again, if this was 1 over that and 1 over x plus 2 over x minus 1, there's nothing I can do. Remember, I can't add. Our keyword is to multiply top and bottom. So I can't add anything. It would be nice to maybe add 1 to x plus 1 and get 2, but there's nothing I could do. I have to multiply. So that's why we have the x plus 2. We have an x minus 1 and an x plus 2. All right, take a look at these two. What is the least common multiple for these two? Again, if these were if these were fractions and I was trying to add them or subtract them, what would I have to multiply top and bottom by to get the least common denominator? See, out of 3 and 6, we definitely need, I'll just call it the LCD, we definitely need 6. Okay, remember it's not the factor, it's the multiple. We have an x plus 3, so we need one of those. We also have an x minus 2, so we need to have that because there's no way I could turn the second fraction into an x minus 2. And we also need an x plus 2. Okay, so that whole thing would be the LCD. All right, take a look at this one. X squared minus x minus 12 and x squared plus 5x plus 6. All right, this one hopefully has some common factors, so let's first factor them. So this one's going to factor into x minus 4 and x plus 3. All right, and this one is going to factor into x plus 3 and x plus 2. All right, so we definitely have a common factor, which is nice. So the least common multiple is x plus 3, x minus 4, and x plus 2. We've got to take them all. Right? So if I had, let's see, so for example, if this doesn't make sense, what if I had 1/2 plus 1/7 plus 1/4? Okay, the LCD for this one, let's see, would it be just 2? No, it would have to be 28 because 4, we can split up 4 as 2 times 2. So we don't need all 3 2's, we just need 2 of them, and then times the 7, so by what's missing. Okay. All right, I think you guys got that. All right, so let's find the least common denominator here. We're not going to actually add or subtract. So what's the least common denominator for 2/3 and 1/4? Yes, 12, good job. LCD is 12. So we would multiply this one. Remember, keyword is multiply by what's missing. So 4 times what equals 12? 3. All right, I know we already did this, but okay. It's helpful to go back to a number example when we're dealing with something that's unknown. Okay, so what's the least common denominator for 2 over x minus 3 and 3 over 2x plus 3? Okay. If you can do this on your own, write it down. Pause it, write it down. All right, there's a keyword is multiply. So I cannot change 2x plus 3 into an x minus 3 and vice versa. Like I can't change them, so I take them both. Just like the LCD here for, oh, that was 12, I take them both. I take 3 times 4, which happens to be 12. So the LCD for here would be x minus 3 and 2x plus 3. And then if I were actually solving this one, I'd multiply by what's missing. So what's missing from the LCD on this side? Good, 2x plus 3 and 2x plus 3. I'd multiply top and bottom by what's missing here, which is the x minus 3 over x minus 3. Okay. All right. Let's take a look at 1/6 over 7/12. What's the LCD here? 12. Good job. All right. So LCD is 12. So I don't need to take them both because I can turn this one into a 12 by multiplying. So for this one, 3x over x minus 2, well, if I factor this, this is going to be x minus 2 times x plus 2. All right. So I already have the least common denominator on the right side. So my LCD is x minus 2 times x plus 2. So I don't have to multiply the right side by anything. If I were really adding these, I would just have to multiply the left side by x plus 2 because that's what's missing. Okay. All right, so let's take a look at this one. Let's find the least common denominator here. Let's see, this one's factored, so let's factor this one. This factors into what? X minus 3 times x plus 3. Okay, and this one's already factored. So let's start LCD. Okay, well we definitely need this denominator. So 3x times x plus 3. And if we look at the second thing, we already have an x plus 3, but we don't have an x minus 3, so we need that. And then the third fraction, we already have an x, and we already have an x minus 3, so we don't need those. So here's our LCD. So if we multiply each one top and bottom by what's missing, we will get the least common denominator for all of them. Okay, so now we're ready. Well, no, now we're not ready. We'll do this. So pause this, see if you can get the least common denominator. Factor it. All right, so let's factor. So if we factor out a GCF, we have x squared minus 4 for this one. And we can factor again, and we have x minus 2 times x plus 2. Okay, so that's that one. The next one, we could factor out a 6. And so we'll get x squared minus 4x plus 4. And we can actually factor that one again. So this is going to factor into x minus 2 times x minus 2. Okay, so the least common multiple, let's see, what's the least common multiple for 4 and 6? 12, good job. Because this is 2 times 2, and this is 2 times 3. So we need both 2's, and we need a 3, and so when we multiply those together, we get 12. We definitely need all of this, so we have x minus 2 times x plus 2. And then this one has 2x minus 2's. So we need 2 of them, so we need to add one more. And why do we need to do that? Well, this one had a 2 times 2, so we needed to add both 2's into our least common multiple. So, and then if this one has 2x minus 2's, we need to add both of them. So that's that. All right, I think we're ready to add now. Yes, we're ready to add. All right, so factor first. So I guess we need to modify. Step 0 would be to factor the denominator. All right, factor the denominator first. So we have 7 over 9x squared plus, what is the common factor? At 3x times x plus 1. All right, so if you can do the rest by yourself, go for it, pause it, fast forward to get the answer. If you don't get the answer, please rewind it and watch it. But, all right, so that's step 0. Step 1 was to find the least common, let's go back up, least common denominator. Where's our steps? Find the least common denominator. And we're just going to put find LCD. Okay. So let's see, we definitely need 9x squared because that's already in one denominator. And do we need the 3x? No, that's in here. So if we split up 9x squared, we'll get 3x times 3x. So that's already in there, and then we have x plus 1. Okay. All right, so now we're going to multiply top and bottom by what's missing. So keywords are multiply and top and bottom. And by what's missing. So what's missing from the 9x squared one? Good, x plus 1. What's missing from the other fraction? 3x, good job. Okay, and then don't forget to distribute. We're multiplying everything. So we have the left fraction becomes 7x plus 7, all divided by 9x squared times x plus 1. Okay, plus 3x squared, and then if we multiply, we have 9x squared over x plus 1. All right, so now we have the same name, so now we can actually add them. So we have the same name, so I keep that name, and then I combine like terms on the top. So I have 3x squared plus 7x plus 7, and I am done. That's my final answer. Okay. All right, so take a look at example 4, factor it. Remember that subtraction. I would actually make a suggestion. So I would rewrite this. See, if we factor this denominator, it's going to be, the GCF is 2, so we have 2 times x minus 1. And then I would take this negative and distribute first, so you don't have to worry about that at the end. So this is going to become positive 2x and positive 1. So that might help you. And then when we factor the denominator, this becomes x minus 3 and x minus 1. All right, so see if you can figure this out all by your lonesome. Okay. Find the LCD, multiply by what's missing, top and bottom. Right, go ahead and try it. Just try it. Interval training. Okay, so let's see, let's find the LCD. For LCD, well, we definitely need all of this denominator, so that would be 2 times x minus 1. And we've already got an x minus 1 there, so that's taken care of, and we need the x minus 3. All right, so what's missing on the right side is just 2, so multiply top and bottom by 2 over 2. What's missing on the left side is x minus 3. Okay, so the LCD, so the left side, and remember I'm multiplying, so I need to FOIL that, put it in a box, distribute twice. But my denominator is going to be 2 times x minus 3 times x minus 1. And when I FOIL this, let's see, I'll do a little side problem. I have x minus 3 and x plus 2. So I have x squared, negative 3x, positive 2x, and then negative 6. So that's going to become x squared, combine like terms, minus x minus 6. Okay. And then plus, here's my common denominator. And then I'm going to distribute. Don't forget to distribute. So that becomes 2x, just kidding, it becomes 4x plus 2. Okay. All right, am I done? No. Okay. So I want to keep the same name. I'm almost done. Keep the same name. So my name of 2 times x minus 3 times x minus 1, and then combine like terms. So x squared, and then these are like terms. So negative x plus 4x is a positive 3x. And we've got negative 6 and positive 2, so that would be a negative 4. And then the question is, can it reduce? Well, I don't have any multiplication on top, but does it factor? Let's see. If I have x plus 4 and x minus 1, it actually does factor. So, because that middle term adds up to 3. So now I have this. Can anything search and destroy? Yes, this x minus 1 can reduce with this x minus 1. So my final answer is that. Okay. All right. So if you fast forwarded and didn't get that answer, but you got this answer, please rewind and just watch just a little bit more. Okay. All right. So you try this one. Try it all by yourself. You can do it. Try it. Okay. You can do this. You can do most of it. You can do this. So just pause, factor the denominator, things like that. Okay. So we have x plus 1, and then this factors into x plus 3 times x plus 3 plus 6 over x minus 3 and x plus 3. So when we find our LCD, we have, let's see, we definitely need all of the first denominator, x plus 3 twice. And we already have an x plus 3, so the only thing we need left is an x minus 3. All right, so that's our LCD. So now we're going to multiply top and bottom by what's missing. So what's missing from the left fraction? Get x minus 3 over x minus 3. What's missing from the right one? Another x plus 3. Good job. Okay, are we going to have to FOIL, distribute, multiply in a box? Yes, we will, because we need to multiply that. Make sure you multiply that. All right, but first, let's see, that's right. We've got our LCD of x plus 3, and you can write that as x plus 3 quantity squared if you'd like. Or you can just write twice of two of them. Right? And then, so when we distribute that, let's see, I'll multiply it in a box. We got x minus 3, x plus 1. We've got x squared, negative 3x, positive 1x, negative 3. So the left fraction is going to be x squared minus 2x minus 3 plus our LCD. Let's see. Doesn't really matter what order you write them, but we have our LCD. And then make sure you distribute the 6. So when I distribute the 6, I'll get 6x plus 18. Okay, so I have the same name. So I'm going to keep that same name, the LCD of x plus 3 twice times x minus 3, and then combine like terms. So let's see, I only have 1x squared, and then I have a negative 2x and a positive 6x, so that's a positive 4x, and a negative 3 and a positive 18, so that's going to be a positive 15. That does not factor, so that is your final answer. So if you got that all by yourself, you are awesome. Good job. If you got most of it, but then you watched the rest and figured out how to do it, that is awesome too. Okay. And let's see. So here is all your guided practice. So all of that, and then 1 through 4 from the very beginning. Okay. Have a good night. I will see you tomorrow.